Okay, vectors unit review. The thing with the vectors unit is that there are a lot of little equations. The math, the arithmetic is all very easy, but you have to know what to do when. So what we're given with these first three problems is we're given 2 points and we need to find the vector that starts at P, has an initial point at P, and has a terminal point at Q. So that vector would look like this. P to Q. So the way that we do that is to subtract. We do our Q coordinate minus our P coordinate with the horizontal components and the vertical components together. So here's how this looks. We do our, if you really want to think about it as a formula, your horizontal component is x2 minus x1, and your vertical component is y2 minus y1. And that makes your horizontal and vertical components of your vector. So if you need that equation, if you need to make a note of that, there it is. Here's how we would use it with this first problem. So our horizontal component is going to be negative 3 minus 4. Our vertical component is going to be negative 6 minus 2. And that makes the vector with the horizontal component negative 7, vertical negative 8. That's in component form. In the A plus AI plus BJ form, you would write that as negative 7i minus 8j. The reason I have 3 examples of this on the review isn't because the math is difficult. It's just because that it's easy to forget what to do in this context, and it's easy to think that you have vectors when really you have points. So that helps you to label your points, kind of like we would with point float, and then go to your vector. Our x is 3 minus negative 2. Our y is 6 minus negative 3. In component form, that's 5, 9. In AI plus BJ form, that's 5i plus 9j. The nice thing about vectors is three-dimensional vectors work the same way. Everything is consistent. So if we're doing a three-dimensional vector, we will do our x's, our y's, and our z's. So our x, 4 minus 2, y's, 1 minus 3, z's, negative 1 minus 3. So that third dimension doesn't make things more difficult. 4 minus 2 is 2. 1 minus 3 is negative 2. Negative 1 minus 3 is negative 4. And in the ij form, it's I, j, k. 2i minus 2j minus 4k. Again, that's not, the math isn't hard. Knowing what to do when can be a little bit challenging. Same thing with this next one. We're adding 2 vectors and finding the magnitude and direction of the results. So the first thing we want to do is add the vectors. I do want to see you add the vectors on the graph as well, but you can just add their components to check your work. So when we're adding vectors, unlike when we started with points, when you have the little like triangle guys, you know we're starting with vectors. So we just add our horizontal components and the vertical components. So the resultant vector is negative 2, 10. Now to show that on the graph, I like to start at the origin. And so I'm going to do this first vector first, negative 4, 7. So my horizontal component is negative 4, so I'm going to go 4 in the negative direction. My vertical component is 7. And pretend like that's a straight line there. And then I'm going to do the head to tail method. So from there, I'm going to go 2 in the positive direction, in the positive horizontal direction, and 3 in the positive vertical direction. So 2 horizontal, here's the head of my new vector, 2 horizontally, 3 vertically. And my resultant vector that starts at the origin and ends at my final point there is negative 210. So that's how you show that graphically. Now we need to find the magnitude and the direction of the resultant vector as well. The magnitude is the square root of the squares. So we take our 2 horizontal component and our vertical component to find our magnitude. We're really just doing the Pythagorean theorem. The magnitude is the same as the length of the vector. That gives us the square root of 104. We need to break that down. Square root of 104, we can break that down into square root of 4 and square root of 26. So our magnitude is 2 square root of 26. Last piece is our direction angle. We're going to use our tan. Of our vertical component divided by our horizontal component. And the thing with your calculator in this unit that's different than all of our others is you want to be in degrees. So you're going to want to make sure you switch your calculator over. My calculator is still in polar coordinates because I was making polar coordinates videos this morning as well. And that doesn't matter because we're not graphing any functions today. So I'm going to do, since that's not, 10 over 2 is not going to give me a unit circle value. I get negative 78.69. And I know that I need to add 180 from my equation sheet. Our equation sheet says that. You also know if you're looking at your quadrants here, you're in the second quadrant. And when we're using arctan, we get values only in quadrants 1 and 4. So 101.309. Or 101.310 if we're going to round. I'm fine going 3 digits, truncated or rounded. So that was 1, 2, 3, and 4.